The prime cross, a look into prime numbers. So what is a prime number? A positive natural number greater than 1, which is only divisible by itself and 1, is known as a prime number. So an example of a prime number, 23. It's a prime number because it's only divisible by 1 and itself, whereas 24 is not prime because it's divisible by 1, 2, 3, 4, 6, 8, 12 and itself. The sieve of Eratosth's algorithm can be used to generate prime numbers to a given limit. There are other algorithms, but this one's pretty fast. It's of time complexity O of n log of n. The algorithm itself. Here is the algorithm in Python. It's only about a dozen lines of code. We can generate primes fast. Here are all the primes up to 100. We can generate all the prime numbers up to 1,000,000 in a fraction of a second. Plotting primes. We can plot primes in a number of different ways to try to observe patterns, and this is what people have done over time. And then we can get some bigger patterns with bigger data. So for example, on the left-hand side, we have the Sachs spiral, and on the right-hand side, we have the Ulam spiral. Then there's the deep analysis. We can deep dive into primes and pull out all kinds of theorems and concepts. So, prime points, a new concept. We define a prime point as a tuple made up of two prime numbers. The x component we'll call prime x, and the y component we'll call prime y. The origin is 0, 0. So, our prime point recipe. For each number n in the prime sequence, we generate the prime points as follows. Step 1, x plus n, y plus nothing. Step 2, x plus nothing, y plus n. Step 3, x minus n, y minus nothing. Step 4, x minus nothing, y minus n. And we do this until the sequence is completed. Here is our prime point code. This is the code for generating a sequence of prime points that we observed earlier. And we can generate all our prime points up to 100 or any number of prime points. These were generated from the create_primes algorithm that we wrote in Python with an input of 100. Now we set about plotting prime points to see if we can observe a pattern. Here are the points for primes up to 10. We note that we start at the origin and then sequentially move out to 0, 2 and then 2, 3 and so forth, making a spiral. We do this for points up to 20, again starting at the origin and moving outwards in a spiral. Here's 40. And then 80. We're beginning to see a pattern. Here's 1,000 points. 10,000 points. Well, this is looking like a cross. 100,000 points. The cross is beginning to look like two complete straight lines. 1,000,000 points. 10 million points. This is known as the prime cross.